Next, we will use Packet Tracer 7.1 to simulate smart house automation with IoT devices. Smart house automation is one of the IoT applications which can help to reduce cost and conserve energy. Here we have a simple floor plan for a house that will be used to convert to a smart home. In this simulation, we will show how the IoT devices configure it to be remotely controlled and also how the devices are automated by the sensors. In this smart house, the areas that will be upgraded using IoT devices are living room, bedroom, kitchen, house front, garden, and garage. These IoT devices included will be configured accordingly. In this simulation, this table is used as a guide when doing the configuration for the devices. Generally, there are 3 configurations sections. The first device need to be configured is the home gateway, which acts as the control point of all IoT devices, and also as a connection point to outer network and in devices such as mobile phone and PC for monitoring or control the IoT devices. Typically, home gateway is a broadband router which allows the connection of a local area network to a wide area network. Secondly, the IoT devices and sensors need to be configured to connect to the home gateway. In this case, the devices are configured so that the IP addresses are auto-assigned by the DHCP. Lastly, the end devices need to be connected to the network so that the IoT devices can be monitored and controlled. In this simulation, only local area network is used. Thus, the end devices must be connected to the same network as the home gateway and the IoT devices. Now, let's start with the Packet Tracer simulation. Firstly, all the devices are arranged as shown here. We use cables to connect some of the devices to the home gateway as stated in the table. Note that fast Ethernet port is used during the cable connection. The rest of the devices are expected to connect to home gateway via wireless connection. At this stage, none of the devices are interconnected with each other. To let the devices to be interconnected, these 3 steps need to be followed in sequences. Step 1. Home Gateway's configuration. Go to Home Gateway's configuration menu. Under the Interface section, go to the Wireless settings. Notice the SSID is Home Gateway. As authentication purpose, we need to configure a password. In this case, WPA2PSK is used and it is mandatory to set the password with a length between 8 to 63. Upon setting the password, the encryption is AES by default. Step 2. IoT devices set up for IP address allocation. The configuration for IP allocation is different depends on the connection method. In this simulation, we have 4 devices connected to home gateway using cable connection. The rest are using wireless connection. For the devices using cable connection, the configuration goes like this. In the Devices config menu, under Global Setting, set the IoT server as home gateway. Then under Fast Ethernet 0, select DHCP for the IP configuration for the device. Once checked, there will be an IP address allocated to the device. On the contrary, for device using wireless connection, the steps are, by default, the devices only have Ethernet network adapter. Thus, additional network adapter for wireless connection is needed. To add or modify network adapter, click on the Advanced button, and IOconfig should be visible after clicked. Go to IOconfig, select PTI in W1W. Then, go to the config. Under Global Setting choose Home Gateway as IoT server. Next, go to the Wireless 3 settings. Set up the authentication session and use the same password used when configuring Home Gateway. Upon password is set, the IP address will be allocated to the device. Notice there is a change in the Packet Tracer interface. This means wireless connection is successfully established. In step 2, the rest of the IoT devices are configured using the method stated to be connected to the home gateway. Once done configuring all devices, interconnection network is established.
Created using Powtoon.